being a famous YouTube person, because that's that's where it gets put. So, well, guys, I hope you're ready to roll tonight. I'm going to jump into some things, and um, we're going to learn all about integers tonight. And so that's what I have here on the screen here. So um, let me, oops, I just made myself small. Made myself go away. Um, let's see here. I think if I do this, it gets nice and big. Okay, and then I can drag this over here a bit. Maybe that stays. Yay, that stays. All right, guys. So first of all, I want to, before I forget to mention this, this is to all my 70s, okay, ATS 70s. There is an exam in WAMAP scheduled for this week, and tonight is January 26th, Tuesday night, and the exam is scheduled in my class. In fact, I kind of just flip over here and show it to you. It's right here. So it's Unit 3, WAMAP Examination 1 on Units 1, 2, and 3. Okay. I want to say a couple things about the exam. First of all, when you can take it anytime this week. If you want to take it, you don't want to wait till Sunday. That's fine. It's worth 40 points. Okay. And I'm pretty sure I opened it up so you could take it now. You don't have to wait till then. But it's going to cover, okay, second thing is the what. It's going to talk about, we learned in the first module, everything to do with adding, subtracting, multiplying, dividing decimals. So it's going to be about that, doing the same with fractions, which is adding, subtracting, dividing, and multiplying. And it's also going to be related to conversions, okay, which conversion means changing a decimal to a fraction to a decimal, a percent to a decimal, etc. We went over all that last week, and I think I made a recording of it as well and sent it to you. But that's all the content that's in there in that video I made. Plus, it's in the modules here. Okay, so those three things: decimals, fractions, conversions on the first WAMAP exam, and you'll take that in WAMAP. In fact, if you don't mind me just showing you real fast, taking you on a little tour here of WAMAP. If I log into WAMAP, I just want you all to be clear where you'll find it. So in my course, which is this one here, 70, if you scroll down, okay, you've got Units 1, Unit 2 was with fractions. We covered that. Conversions was Unit 3, okay, covered that. Then if you scroll all the way to the bottom, okay, you see this Unit 1 examination, okay? It's due by, it says, I have it open till the 17th of March, but it's due this week, okay? And so you click on that and you would start the exam, okay? So I just wanted to be really clear. That's where you'll find it. All right, guys, let's jump into the content tonight and let's talk about understanding integers. So in your notes, you can copy this down, just integers, and then draw a line across it. And I'll give you about 20 seconds here to put some numbers on that. And speaking of 20, I just want to see how far I can go over here and still have my picture be on the screen. Good. All right. All right. As I said in my little sticky note that I can put on here, integers they are all of the positive and negative numbers, okay? And so this term here, integers, okay, whenever you hear that, now as you're getting ready for algebra, they want you to understand that as all the positive and negative numbers. Normally, everything we did before was either just whole numbers, okay? And that was, 1, 2, 3, 4, 5, up to billions and trillions, okay? So you had whole numbers and you had fractions. And you might have even talked about in the past, well, like in this class, decimals, okay? So we had these things in math, okay? But most of it was all related to whole numbers, But when you start talking about positive and negative numbers, they use the term integers. Okay, so I just wanted you to understand why. What is an integer? It's the name they use to talk about all positive and negative numbers. All right. Now, one way to look at and think of integers, or is if I draw this for you guys. If I drew this, this is my thermometer. Okay, we're all familiar with thermometers, and if this right here was 0 degrees right here, and this was 32 degrees, the point of freezing. Okay, um, we're all kind of familiar with that from clocks. What's going on here? I'm trying to let somebody in the class. Just a second. Hang on a second. I want to make sure everybody gets in. Sorry. Uh-huh. There we go. Okay. They disappeared and came back. Interesting. Hello. So we're recording here. So go ahead and turn off your camera if you just dropped in on us, okay? Oh, I can go to this screen here. So we're familiar with a thermometer or a temperature gauge, where we measure things, okay? And one way to think about negative numbers is that negative numbers are all of these numbers that go below zero, okay? And so everything from here below, if I'm shading in my thermometer here, my temperature gauge, these are all negative numbers, like negative 20 degrees, okay? By the way, it got down to 20 in the 20s at my house, I don't know, a couple days ago. But that's one way to think about negative numbers is below zero, okay? And so on the number line, anything obviously to the left of zero here is a negative number. And obviously everything to the right of zero is a positive number, okay? So anyway, that's just like a little introduction to integers. Um, Go ahead and take a minute and write down these. These are symbols, inequality symbols, okay? Or you could just write symbols down as that these are symbols we use in mathematics when we're talking about things being greater than or less than or equal to or not equal to, okay? So for instance, we have the symbol. Oops, I need to just drag this a little out of the way here. That's what happens when I do that. I didn't want it to go at the bottom. Is it okay? Okay, that's not bad. That stays. All right. So we have this symbol right here, and you've probably seen this before in classes. This little thing looks like I like to call it like an alligator's mouth open. Okay, the bigger side of the alligator. Okay, if you can imagine, it's got little teeth in here. Is always pointing towards the greater number. Okay, so if you wanted to put that in there, this side right here is always pointing to the greater number. So you'll notice in my example number 2 here, the symbol is facing the opposite direction as it is in example number 1. But 4 is less than 7. That's how I would read that out loud. I'd start with the first number and I'd say 4 is, and I got the less than, the smaller end of the alligator pointing 7. Conversely, in number 2, 3 is greater than, it's got the big alligator mouth facing towards the greater number, 2. And then number 3 here, I've got 7. This little symbol right here is the unequal. It's like when you ever see this symbol like here and they have like a line through it, no smoking, okay? Um, that's the same idea here, okay? Is that equal sign with a line through it means unequal to. 7 is not equal to 11. And then of course, 1/2 is equal to 2/4. They mean the same thing, okay? So those are some symbols that will come up in this new module, okay? Um, Now, all I want you to do is, in fact, you don't really need to copy anything on this slide, okay? I just want you to watch, and because there's no new concept here, I just want you to just kind of like see it visually, okay? Like an example, okay? If we take the numbers 4 and 0 here that I have in my example here, okay? 4 is here, okay, on the number line, and 0 is here. So if we were to write the comparison using these symbols here, greater than or less than or unequal to, okay? If we were to use those symbols, we would write 4 is greater than, just like it's down here at the bottom left corner, 4 is greater than 0, okay? And it's read out loud, it's spoken as 4 is greater than 0. All right. Now I want you to notice that any number, okay, any number that is further to the right on this number line that I've got my cursor, my little red dot going, any number that's further to the right is considered greater than, okay, than any number that's to the left. So for instance, let me change colors here real fast and I'll pick green, okay. We would say that obviously 3 is greater than 2, okay. If I took my number line further this way and I went like this and went -1 and -2 and -3, okay, even though, now watch this carefully here, even though 3 sounds like it's a bigger number, -3 is less than -1, okay? Why? Because -1 is further to the right on the number line. So if I was to write this as a comparison, I would write like this: -3 is less than -1 there, okay? That's just kind of a little visual of understanding that anything that's further to the right on the number line is greater than. It is larger. Okay. So again, don't worry about taking notes. Just kind of watch what I'm doing here. 3 and 6. If I was asking you to write out which is greater, as a comparison, I would write 3 is less than 6, just like we did before. Okay. And it's read out loud or spelled just like it did before, is less than. Okay. So that's the idea. That's the concept. And that's kind of just understanding those ideas of spelling them out using the symbols. Okay, let me go to my next slide here. I do want you to take notes on this. So I want you to go ahead and write this. This is a kind of an important concept at this point this is a new concept, something called absolute value. Okay, so go ahead and put that in your notes, maybe in a bright colored color. Okay, and when we are speaking about absolute value, there's a symbol right here. I'm going to circle it here. They usually will put those 2 bars around a number, and that means absolute value. Okay. So the definition is the absolute value of a number is the distance it is from 0. Okay. So if I was taking abbreviated college notes, I might write just this: absolute value equals distance from 0. Okay. So I'm going to give you 10 seconds to copy that down. And please copy down these examples in your notes right underneath it. In fact, you might want to even write this: examples. Okay, so these are some examples. So, all right. So if they ask you, if I look at we'll call this number 1 here, okay? If they ask you in number 1, what is the absolute value of -4? Okay. Does anybody know what the answer is? Actually, I better just answer because I'm making a recording, okay? Well, -4, if I choose a better color here, If I circle it on the screen here, okay, this is -4. How far is it away from 0? It's 4 away from 0. So the answer would be just 4. Okay. The absolute value of a number, again, is the distance from 0. It almost seems like too easy once. I mean, it sounds kind of ominous, absolute value, but it's actually just how far is it from 0? That's all it means. Okay. So what's the absolute value of 4? 4. It's 4 away from 0. Okay. If I circle it on here, yeah, look at it, it's 4 away from 0. What's the absolute value of -2? It's just 2 away from 0. 5, it's 5. Okay. All right. So those are some examples of absolute value. How far from 0? Let me see if I have another trick one on the next page. I do. So let's write a couple more of these. Can you guys, I'll give you 20 seconds. I want you to write these down on your notes, and then I want you to answer it. Like, tell me, what is the absolute value of -15, 14, 6, -6, and a -37? There's your trick question, okay? Let's see if you can get them all right. Just guess on this last one. Okay. All right, so I'm going to go through them. The first one, absolute value of -15, 15, absolute value of 14, 14, absolute value of -6, 6. Then we get this trick one, okay? Here's how it would read out loud. What is the negative absolute value of -37? Well, the absolute value of -37, if I was just looking at this part right here, okay, the absolute value of it is just 37, okay? But it's asking for the negative of that, okay? And so that's a little trick question that you might run into, even especially in 76, the next class up. If they throw that, normally you're not going to see that, but I do know one teacher that kind of likes to throw that curveball at students. So I like to introduce this idea. If you see a double negative, in this case with absolute value, then it would be a negative. Okay. All right. Moving on to a new camp concept. I think you guys got that. Um, you'll need to write these down in your notes, guys. Okay. So I'm gonna be quiet for about a minute and let you just copy down what all the writing you see on the screen. Don't worry about the chart. Don't worry about the white piece there. Just copy down what you see on the screen. Okay. It's got to be a way I can do this. Yes, I can do that. Okay. I'm reminded that normally when I teach the class, I have all the notes up on the board, and my students come in and they get there early and they start copying down everything in their notes. And then once they've got all the slides, it'd be basically all on a whiteboard. Then I go through and I talk about each concept, and then they write my examples into their notes. But we don't have a big, huge whole whiteboard, so we're doing it this way. Okay. All right, so we're going to be talking about how to add, subtract, multiply, and divide. Thank you, B.S. Collins, for turning off your camera, okay? Because I'm recording, you probably don't want to be on camera. Okay, thank you. Welcome. We're taking some notes on integers here tonight. Um, so when you're adding and subtracting integers, okay, so just this is the rule. When you're adding, when you're adding integers, okay, if the integers have like signs, add the numbers and keep the same sign. Okay, so that's rule number one. All right. So what I mean by that, if you look at my example, 2 and 2 are both positive numbers. It's like you're saying plus 2, okay? It's a positive number plus 2. Okay, now we don't write it all out like that. Okay, equals a plus 4. Um, when you have the same sign and you're adding numbers, you add up the numbers and just keep the sign. Okay, like here, you might want to underline, keep the same sign. All right. So if I have -2 plus -4, I have the same sign, right? I'm adding two negatives. So I just add them up. 2 plus 4 is 6. But keep the sign. Okay. In this case, it's negative. Okay. So that would be kind of an example of negatives of how you add. When you add and you have the same sign, keep the sign. Just add them up, keep the sign. Okay. Now, visually, I wanted you to see this, and you don't have to copy this down, but I wanted you to see this on the chart here, what this would look like, because some people this helps them when they're adding them to visualize it as if you were on a number line. -2 here. I've got this number here, -2. Okay. That's starting, if I just change color here, that's starting at the number -2. Okay. Um, so I'm at -2 here. Okay. Plus -4. That means I'm going to go 4 this way. I'm going to go all the way to here. Okay. So that is why I've got my blue arrow here. That's what it would look like. We'd start at -2 and go another -4 and get to -6. Okay. On a number line. But the general rule is when you're adding, keep the same sign. Okay. If you have the same signs, just add them up and keep the sign that you have. All right. Next rule. Again, I want you to copy this down. You don't have to copy down the white number lines, but I'm going to give you another 30 seconds to copy down rule number 2. So we're talking about unlike signs now. I'll give you another 25 seconds to keep copying this down. Okay. All right. So previous slide was same signs. Now what do we do when we have unlike signs? Okay. So the rule is when adding integers with different signs, if we have different signs here, we subtract, okay, and then keep the sign of the larger or greater number, okay? That's the rules. You might even want to underline the parts that I underlined on my definition here, my rule, okay? So when I have a +5 plus a -2 here in this first example here, I'll call this example 1, all right? I have different signs there. So what the rule is to subtract. 5 minus 2 is 3. And then I go, okay, is it going to be a positive or negative? The rule says keep the sign of the larger number here. Okay. Well, 5 is the greater number. And so I just keep the sign. It's going to be a +3. And again, we don't normally just write +3, we just write 3. It's assumed it's positive, okay? Look at example number 2 here. I've got -5 plus 2. I have different signs, opposite signs. So I subtract. 5 minus 2 is 3. Keep the sign of the greater number. Which number is greater? Well, 5 is um, 5 is a bigger number. Now I need to clarify something here because it sounds like it contradicts something I said about 6 minutes ago. I told you that on a number line, like -5 is less than, say, like 2, which would be over, like, way over here. Okay, that's 2 here. So technically, it is quite a bit less than. Okay, but the way when they give you the definition of how to add these and subtract them, they call 5 just generally, generically a bigger number than 2, and so that's what they mean by the larger number here when it says larger. Um, so I wanted to clarify that. Okay. So again, at number 3 here, I got 17 and 7. Well, the greater number in a sense is 17, right? So I'm going to subtract 7 from 17. I'm going to get 10. Then I'm going to look and say, okay, which one was the bigger number in a sense? And I'm going to keep that sign. Okay. So that's the rule for adding and subtracting. Let's go ahead and take a look at. I do want to also mention this rule, which um, and you should write this down in your notes. A double negative, okay, equals a positive. All right, when it comes to adding integers, you should just be aware of that a double negative equals a positive. So in my example here, I've got example A, I've got 6 minus, and then in parentheses, a -2. What that means is when you have two negatives here strung back to back like this, right next to each other, okay, it becomes a positive. So it really becomes 6 plus 2, which is 8, okay? Another example is if I had a minus -8 plus 4, this becomes a positive, and now it's just 8 plus 4, which is 12, okay? But I did want to mention that in case you see that in your homework or on a quiz or something. If you see when you're adding integers a double negative, it means it becomes a positive. All right, let's move on to the next rule. Actually, let's practice a little bit. I want you to, even though you don't have your microphones on, I want you to answer these out loud, and you may want to just write the examples on your paper just for more practice. This is almost like you're doing some homework, but we're doing it together. If I had, and you can write this down on your notes, okay, 10 minus a -6, what would the answer be? Okay. All right. If you're thinking this is 10 minus a minus means it's plus now. So it's 16. If that's what you're thinking, you're thinking right. Okay. That's really 10 plus 6. If I had 22 minus a -16, that means 22 plus 16, which is 22, 32, so 38. Okay. So you can even write this in your notes just so you have more examples to see visually. Okay. Again, in fact, that's about enough. So anyway, I think you guys got the concept, but let me go down to number 7 here. Look at this number 7. I have, yeah, this is a good one. You probably should write in your notes, okay? You might want to even circle it. I have -17 minus 7. Now there's no double minus here, okay? So what that is, if I was on a number line here, okay, and if this was 0 and I was all the way, to -17, okay, on my number line, okay, you don't have to copy this down, okay. But if I was at -17 minus 7, it means I'm going to go this way 7 spaces, okay. So if I add them up, 17 plus 7 is 24, right? That sounds about right. Okay. And it's a -24. Okay. Now, if you wanted to think about it kind of like the rule I just taught you about adding, if you add the same sign, this is just like you're saying -17 plus a -7 equals, and remember the rule, when we have the same sign, two are negatives, we keep the sign and just add them up, okay? All right, that's a little bit of practice. Let's move on. All right. All right, now this has to do with what do you do when you have more than two numbers. So I'm going to give you another 30 seconds or so just to copy down what you see on the screen here. I'll give you another 20 seconds here. Okay. Um, so I've got a little note that I drew down here. It says note about shortcut. Okay, and I put on my to remind myself. If they ask you, like example one here, in example one, add 32, which is a positive 32, plus a negative 13, plus a negative 8, plus 4, plus a negative 22. The long way to do that, it's a little bit harder, is to go like this, okay? To go, okay, I got positive 32, this is minus 13, so that would be 22 minus 3 is 20, that'd be 19. This would get me to 19, okay? You combining these two, and then plus negative 8, so that's subtracting 8 from that. That gets me to 11, okay? Plus 4 gives me 12, 13, 15. I now have 15. Minus 22, well, I'll subtract these, so 22, 50, that's 7, that'd be a -7 equals -7, okay? I think I did that right, real fast in my head, hopefully. All right. Now, that's kind of the way I learn how to do it, is go from left to right and just calculate as you go. Okay. But I do want to tell you a shortcut. Okay. To do these a little bit faster. Okay. And let me illustrate my shortcut on the example number 2. If you're just adding and subtracting, that's all you're doing here. Okay. All the way across. It's not a good example for number 2. Forget number 2. Go back to number 1. If you're adding and subtracting, you got positives and negatives. What you can do is treat them separately and add them all up separately and then calculate. Here's what I mean. You see how I've got a positive 32? I'm just going to take all my positive numbers. Okay, I'm going to go over here to, I've got positive 4. So that would give me a positive 36. Okay, and that's all the positive numbers. So it's going to be 36. Okay, all right. Then all my negative numbers, I'm going to add them all up. So 13 plus 8 is 18, 19, 20, 21. That's negative 21 minus 22, which would be a negative 44, 43 minus 43. I think I did that right in my head. Okay. Let me check it. Minus 22 or 20. 13, did I do that right? 8, 9, 10, 11, 18, 19, 20, minus 21 plus a minus 22. Yeah, minus 43. All right. So now I've broken it down by just combining the like terms, the pluses and the minus together to something. I got 36 minus 43. Remember the rule, if you have, you subtract, so 43 minus 36, okay? Which would be 4, 7, okay? and you keep the sign of the bigger number, which is -7. Yeah, we did do that right. Okay. So that's the shortcut. When you are adding integers with more than two numbers, and there's a list of them, and they're positive and negative, you can treat them separately and add up all the positives first, write them down, add up all the negatives, and then now you have two numbers to work with, okay? In the case of my next example, number 2, I have a positive 15, okay, okay, and then this minus a minus 13 makes it a plus 13, okay, and then the rest are all just negatives. So that would be 30, 28, okay, a positive 28, and then my minuses, okay, so I've got minus 12, minus 22 is 32, 33, minus 34, okay? So this is now my equation by combining my like terms. 28 minus 34, which would give me a negative 6, okay? Because I've got a minus here that's bigger than the plus. All right, that's a little bit about adding things up more than one number. I'm going to skip this for the sake of time. This is just another example that of how you could do this. I have pluses and minuses and stuff. I would add up all the pluses first, write them here, add up all the negatives, might write them there, and then deal with from there. Okay, I think you guys got the concept. So, and I want to make sure I don't run out of time here. So, all right, multiplying and dividing integers. This is a slide you definitely want to copy down. So I'm going to be quiet for about a minute or so here and let you copy down everything you see on the screen. I see my I see my examples are backwards over here. I apologize for that, guys. I'm going to fix that. Negative times a negative, okay, is a positive. So sorry, guys. And then a positive times a negative. Okay. I think I typed them wrong and then I came back and fixed it, but I forgot to fix this part. So negative times a negative. So this would be this right here. And then I have a positive times a negative would be a negative. Okay. That's how that should look, guys. I apologize for that. Okay. I hope you guys are doing okay here. Okay. So here's the rules. Okay. Well, first of all, I want you to notice something. You know, there's only three scenarios when you're three possibilities when you're multiplying negative and positive numbers. It's either scenario number one here, rule number one, where you have a positive times a positive, okay? And whenever you're multiplying a positive times a positive, the answer is a positive. I want you to look at your answers first down in this column over here, okay? You'll notice that in most of the cases, it's always a positive answer, okay? There's if you wanted to shorten the rules of multiplying integers to one rule, it's this one down here, okay? if you can remember that when you multiply a positive times a negative, okay, when they're opposite signs, okay, opposite signs, then the answer will be a negative. In all other cases, the answer will always be positive. So if I'm multiplying, 2 plus 2, 2 times 2, it's 4. Okay, 7 times 7, it's 49. Okay, a negative times a negative. Okay, like a negative 2 times a negative 2 is a positive. Negative 7 times negative 7 is a positive 49. Okay, so sometimes for some students, if they're thinking, I get them confused if I multiply negative, if you just remember one rule, and that is this rule number 3 here, remember that that's the only case when you're multiplying two numbers. That's the only case where you're going to get a negative answer here, this negative, okay? And in all other scenarios, and there's only two others, you're going to get a positive answers. All right. So opposite signs in multiplication, like pluses and minuses, mean you're going to get a minus answer. All right. Um, let's do a couple of examples here. You can copy these down. You're certainly welcome to write them down here. Okay. Um, just to review, I have these symbols here, these brackets, like they're actually called parentheses. Okay, when you have them next to anything, okay, it means times. Okay, so 6 times 2 is those are positives equals a positive 12. Okay, a negative 4, and again, it's next to something in parentheses, right next to it. That means times. Okay, and I'm gonna write myself a little note here. That's what this means. Okay. Um, That's a negative times a positive. Oh, there's my scenario where the symbols are opposite. So I'm going to have a negative 28. Okay. Again, 3 and a negative 8. Those are opposite signs. So my answer is going to be a negative 24. Negative 2 times 5. Oh, I have the same sign. I'm going to have a positive answer, 10. Okay. All right. So that's how to multiply integers. Okay. Now, if your brain's going, I'm not sure if I'm going to remember that, you're just going to have to study it. You're going to have to, sorry if I changed my slide here. You're going to just have to kind of really focus on this for a while, really kind of study it, and then really practice it with examples like this. Always remembering that when you're multiplying, you only get a negative answer in one case, and that's when the signs are opposite. All right. I do want to talk to you a little bit about dividing here, okay? So I've got down on this bottom of the screen here some examples of dividing, and I'm going to tell you how I learned this, okay? Just how it works in my brain. So I know that 18 in anything over something like a fraction like this means dividing, okay? This is the same thing as saying 18 divided by tres here, 3 here, okay? So I know that 3 goes into 18 6 times, okay? Now it's a positive answer here because we have two positives, okay? Let's see if the rule's the same, and it is. I'm just hinting at it, okay? Do you see how I'm dividing here? I've got the same equation down here at the bottom of the screen here, but in this case, I have opposite signs, don't I? What was the rule in multiplying? Opposite signs mean negative. Same thing. Let's see if it holds true. Negative 18, 3 goes into 18 6 times, and the answer is negative 6. Now, here's how I learned this, in case this helps you with your thinking. This is how I learned this. I would go negative 18, 3 times something. This is how my brain goes. 3 times something gives me negative 18. Well, I know it's 3 times 6, but how am I going to get a negative 18? It's got to be a negative number. A positive 3 has to be times a negative 6 to get a negative 18. That's how I learned this, okay? But the other shortcut is to know that if the signs are the same, the answers are always positive. If the signs are opposite in multiplication and division, answer is negative, okay? All right, moving quite some more practice here, okay? And you can write these examples down if you would like to. But um, I've got negative 24 divided by a positive. I've got opposite signs. I can literally go like this. I can write in the sign right here, okay? 6 goes into 24 4 times, okay? And if I wanted to check this, I would go like this. If I multiplied 6, a positive, times a negative 4, I would get a positive times a negative. I'd get a negative 24, okay? 318 divided by -3. These are opposite signs, so I'm gonna have I'm gonna have a minus, a negative answer. 3 goes into 18 6 times, so it's gonna be a -6, okay? And again, I can check. No, I did something wrong there, didn't I? -3 times a -6, it's gonna be a positive, isn't it? How did that happen? Did my rule not 8 divided by -3 has to, okay, my rule didn't hold true. I apologize. I'm thinking out loud here. It held true on the other examples, but here's why it doesn't hold true here. Listen to this carefully. -3, I know that 3 goes into 18 6 times, okay? But what do I have to multiply a negative by, -3, to get to a positive 18? I have to multiply a negative times a negative, okay? So, um, so is it -6? -6, yeah, oh, okay, it is -6. Sorry, guys, I spaced out. All right, I was just not thinking correctly. So it's -6. I had opposite signs, I got -6, okay? Um, Look at this next example, 21 and 3. I have the same signs, okay? If the rule holds true, then if I have the same signs, it's gonna be a positive. Well, I know 3 goes into 21 7 times, okay? Now, if I think about it logically, a -3 times a positive 7 would give me a -21. Okay, so sure enough, yeah, that's the right answer. Okay, so it looks like my rule is true that when we multiply and divide integers that are opposite signs, that's when we get the negative number. All right. In the next case, number 4, I both have the same sign, negative to negative, so I know my answer is positive. 9 goes into 45 5 times, just a positive 5. 22 and -11, that's opposite signs. I know my answer is going to be negative. 22 goes into it twice. Okay. Okay. And thinking about it logically, a -11 times a -12 gives me a positive 22. Okay. In 6, I have the same signs, so my answer is positive. 4 goes into 36 9 times. In number 7, 16 divided by -2, I have opposite signs. I'm going to have an opposite answer or a negative answer. 2 goes into it 8 times, okay? And then this next one, I happen to know that 13 goes into 39 3 times, and I have opposite signs, so it's negative. All right, enough of that. Let's move on, okay? All right, order of operations. Just a little help with this. Um, First thing I'm going to tell you is in your handout, you guys have a handout, okay? And it explains PEMDAS, this concept of PEMDAS, which is the order of operations when you are working with a group of numbers in a row, okay? So I'm going to be quiet for about a minute, let you copy some of this down, especially the first part at the top half of the slide. Facts, I'm going to just put these on the screen here. There's a handout for it, but hopefully we won't run out of time here before my next class comes in here. You do parentheses first, you do exponents, you multiply, and I'm going to put down from left to right. You divide, this is a D here, sorry, it looked like an O. Divide, left to right. You add L to R, and you subtract, okay? L to R, okay. All right, that's PEMDAS, okay? That is the order of operations when you're doing a multi-step problem in a row, okay? Those are the 6 different rules, and that's the order that you do them in, okay? So parenthesis. So for instance, if I look at my problem here, I've got it says I've got this whole problem here, okay, that I'm underlining. I've got things in parentheses I should do first. So -6 times a +2 is a -12. Okay, okay. And then I've also got something over here. I've got that's in parentheses. See the rule here? I'm going to draw an arrow to it. We do what's in parentheses first. Okay. And if you're wondering why does it matter what order? Because you get a totally different answer if you don't follow this order of operation. Okay. That's why it matters. And you'll get the wrong answer. Okay. So I've got, and then I've got 3 times 5 is 15 divided by 3 is 5, right? 15 divided by 3 is 5. So this is 5, okay? All right, I'm gonna put around this equals. All right, so now I've got, so I did what's in parentheses first. 3 times 5 is 15, and it is 5, okay? -6 times a +12 is a -12. Now, I go to the next thing. I did everything in parentheses first, okay? Then the next rule is exponents. So if I pick another color here, just to kind of help it be visual, this is my exponent thing here, okay? I'm gonna do that next, okay? So if I do my exponent first, okay? Um, um, oh, I better hold off on letting people in. It must be my next class. So exponents, 4 squared means 4 times 4 is 16, okay? So that is, now I've got a +16 -12 -5. Well, if I combine my like terms here, that's -17. So I have 16 minus 12 and 5 is 17.
No.
17.
On there?
Whoever just came,
No, he's not. The reason is because he's on a class already.
yeah,
Your class starts in like
hold up a second.
first 2, I think.
I'm going to hang on a second. Sorry, I'm going to. Yeah, go ahead and mute your microphone if you just came in. Okay, there you go. Thank you. I just muted everybody. All right, sorry. I'm finishing up. So so I've got a negative. I got a 16 minus 7 would give me a -1. Okay, so that's the order of operations. Following that, so just wanted you to kind of have that down because you'll probably run into a little bit. You'll run into some problems like this one, this example here, where you're going to have a line of things to do. And if you've written down the notes, do what's in parentheses first, then do the exponents, then multiply from left to right, and then divide from left to right, then add from left to right and subtract. That spells PEMDAS, and that's the rule for order of operations. Okay, moving on. I want to look at just a couple of integer word problems here in my last 4 minutes here of class, okay? You don't have to copy these down. I just want you to see, want you to hear how I do these, okay? Mary is very interested in the study of very low temperatures. She is doing an experiment where she cools a sample of bacteria to a temperature of -61 degrees. You see how I'm writing the numbers on the page, okay? And another, so to a temperature of -61 and another to minus, so she's got 2 different things she's cooling. One's to -93, okay? All right, what is the temperature difference? This word here, difference, see how I'm highlighting this? Between the two. Well, if you subtract the difference between 93 and 61 is 32. They're 32 apart from each other. That's the answer, that's the difference, okay? Because it's just asking for what's the difference in the 2 experiments. So it just wants to know how far apart they are. They're 32 away from each other, okay? So it would be choice number 8, 32 away from each other in that particular one. Watch how I do this next one here. This is a little bit complicated, but I wanted you to see it for me. On Monday, a postal carrier delivers 4 checks written for $10 each, okay? So these are four checks for $10. They're assuming that this is positive, okay? You're getting checks, you're getting money, you're getting paid. So 4 checks for $10 each, and 3 utility bills for 15. A bill is minus, okay? You're getting billed for something, minus, okay? if you had a starting balance, if you start, you're going to start with this much of $35. Okay, you're going to start with 30 in your bank account. So you start with $35. What is the correct expression, which means what's the correct formula for this, for finding the ending balance? Okay, so we're starting with 35, okay, $35. That's what we start, okay? And then it says, so if I look down at my options here in the last minute here, plus, okay, delivers 4 checks. So it's plus 4 checks for $10. So it'd be like this, 4 times 10 minus, because it says bills for 50. Then we have 3 times 15, okay? All right, that's the expression, that's the formula for it. And if I that gets me to this, which one is it? Okay. That would be the expression. So what I wanted you to see from my last class, is that anytime you have, if they ask for an expression, they're asking for kind of like what would be the formula, setting it up like an equation, okay? And I did want to, in conclusion, I want to let you know that you will have some story problems like this and others. You'll have some story problems that will ask you to do this kind of thing. So here's my hint for your story. Write down all the numbers. First thing you do when you watch this, I see an equation. Take the story out of it, right? This is a balance of, this is a positive 475, okay? Write down the numbers, okay? And you've got 65 here, you got 65, 7, okay? And sometimes just writing the numbers from the story on paper, and then you can start reading the thing again a little bit, and it helps you start figuring what you're trying to do there, okay? All right, guys, it's exactly 7 o'clock, so I must let you go. Here's what I'm going to do. I'm going to stop sharing. I'm going to stop my recording just so I can stop recording.